All right, so you've given us this really interesting challenge, a bunch of academic papers on the modularity of mind.
Uh-huh.
It's this idea that our brains aren't just one big mass of thinking stuff,
Right.
but kind of organized into separate units, these modules,
Yeah.
almost like a company with different departments, each with their own
Yeah.
specialized role.
Exactly.
So are our brains like a collection of mini brains?
That's a great question, and that's really what we're going to try to unpack today.
Yeah, let's dive in
Let's do it.
and see what these papers reveal.
Sounds good.
So maybe you can start by just giving us like a clear definition of what exactly is meant by this modularity of mind thing.
Sure. So when we talk about modularity of mind, we're talking about the idea that the mind is structured into these distinct, specialized modules or units, each responsible for processing a specific type of information or carrying out a particular cognitive function.
Okay, so it's not just this one big mushy brain doing everything.
Not exactly, no.
Okay, so where did this idea come from? Like, is this a new concept or has it been around for a while?
Well, the idea of modular mind has roots going back to philosophers like Franz Joseph Gall in the 18th century, but it really gained traction in cognitive science with Jerry Fodor's work in the 1980s, particularly his book, The Modularity of Mind.
Oh, I see.
He argued that certain mental processes, like perception and language, are handled by these specialized modules that are, to a large extent, independent of other cognitive processes.
Okay, so these modules, they have a degree of autonomy, like they're doing their own thing without constantly checking in with the rest of the brain.
Right, that's the idea. And Fodor called this informational encapsulation.
Informational encapsulation. So what does that mean exactly?
It means each module has limited access to information, working only with what's relevant to its specific domain.
So it's like each department in a company focusing on its tasks without knowing everything going on in other departments.
That's a really good analogy, yeah. A classic example of this is the Muller-Lyer illusion, those two lines that are the same length.
Oh, yeah, I've seen that one with the arrows,
Exactly.
where they look different lengths even though you know they're the same.
Exactly. Even when you know they're the same length, your visual system still gets tricked. Why? Because that visual module, the one processing those lines, is somewhat sealed off from your general knowledge. It's informationally encapsulated.
Wait, so even though I consciously know they're the same length, my brain is still fooled. That's so weird.
It is pretty counterintuitive, right? But it highlights how modularity can work. Even when you know the truth, your brain might perceive things differently because of how these specialized modules operate.
Yeah, that's a great example. It really shows how our brains can work in ways that we don't always expect.
Yeah.
So this concept of modularity, does it extend to other cognitive functions too? Like what about language?
No, that's a big question, and one that's caused a lot of debate among researchers. Some argue that language processing is a prime example of a module. It's fast, automatic, almost like a reflex. We understand speech without consciously analyzing every word and grammatical rule.
That's true. I never really thought about it that way, but it makes sense.
Right.
Yeah.
But here's where it gets tricky. There's also research suggesting that language processing might not be entirely modular. Really, yeah. Studies have shown that the context of a sentence, the meaning, the pragmatics, like what's implied, can influence how we understand it.
So our knowledge of the world and the situation we're in actually affects how we process language. So it's not just this isolated module working by itself.
Exactly. And that's one of the reasons why the tasks researchers use to study modularity are so important. Different tasks can tap into different levels of processing and might give you different answers about how modular a particular function is.
Right. So if you're just asking someone to match sentences that are similar, that might tell you something different than if you ask them to explain what a word means.
Yeah, it's like using different tools to examine the same object.
I remember one study from these papers that used ambiguous phrases like landing planes.
Yeah.
And it showed how the way we understand that phrase changes instantly based on the words around it, the surrounding sentence.
That's the research by Marcelin Wilson and Tyler. Really interesting stuff.
Yeah, it really highlights how context and meaning plays such a huge role, even if there is a dedicated language module.
Definitely.
So it sounds like there's no easy answer to this question of whether language is truly modular or not.
That's the thing with cognitive science. There are rarely easy answers.
Right.
It's complex, but that's what makes it so fascinating.
Exactly. Well, these papers also talk about something called central systems in the brain.
Mm-hmm.
What are those, and how do they relate to this whole modularity thing?
Okay, so central systems are those higher level cognitive functions, the ones responsible for thinking, reasoning, problem solving, the things that make us really smart in a sense.
Right, so not just processing input like seeing or hearing, but actually doing something with that information.
Exactly. And distinguishing between these central systems and those modular input systems like vision or maybe language brings us to something Fodor called the frame problem.
The frame problem. Okay, that sounds a bit intimidating.
It sounds complicated, but think about it this way. You decide to make breakfast. You don't mentally review every single fact you know about cooking, your kitchen, food, right?
No, definitely not. I just kind of get going.
Exactly. Your brain somehow narrows down the relevant information. The frame problem is the challenge of figuring out what information is relevant to a problem without considering absolutely everything you know.
Ah, okay, so it's like our brains are incredibly efficient filters. We don't get bogged down in irrelevant details.
Exactly. And this filtering process seems so effortless for us humans.
It really does.
But it turns out it's incredibly difficult to replicate in artificial intelligence.
Yeah, I can see how that would be a huge challenge for AI researchers, trying to program a robot to make breakfast.
Exactly. And that's where modularity might offer a solution, at least in theory. Modules, by their nature, might help solve the frame problem because they only have access to a limited set of information.
Oh, I see. So instead of having to consider every single piece of knowledge, each module just focuses on its specific task, making the process much more manageable.
Right.
So it's like each module is a specialist, and it only gets called in when its expertise is needed.
Yeah, exactly. Like having a dedicated chef in your brain who just focuses on breakfast.
I like that analogy. But if modules are so good at solving this frame problem, does that mean our central systems are modular too, like our thinking and reasoning abilities?
Ooh, now that's a great question, and it leads us into some of the big debates surrounding modularity.
Oh, okay, so there's pushback against this idea of a completely modular mind.
Well, there are definitely challenges, even from people who generally support the concept.
Oh, so like what kind of challenges?
Well, for one, some researchers argue that the frame problem doesn't even really exist.
Wait, what? So they're saying our brains don't have this problem of filtering information after all.
Essentially, yeah. One alternative idea is what's called the sleeping dogs strategy. It's like imagining you have this massive database of information.
Okay.
And when you need to solve a problem, you only update the pieces of information that are directly relevant.
So instead of having separate modules for everything, it's more like our brains have this huge library, and we only
Yeah.
pull out the specific books we need at any given time.
That's a good way to think about it.
Okay, that's interesting. So it's not necessarily separate modules, but more like a dynamic system that can access and update information as needed.
Yeah, exactly.
Wow, this is getting pretty complex.
It is. There are a lot of different perspectives on this.
So what other challenges are there to this whole modularity idea?
Well, some philosophers argue against the modularity of logic.
Logic, like the rules of reasoning?
Yeah, exactly. They say that if the principles of logic are supposed to apply to all domains of knowledge,
Right, logic is kind of a universal tool.
right, then maybe we don't need a separate logic module in the brain.
It's more like a general process that our minds use across the board.
Precisely. And then you also have connectionist models, which emphasize the interconnectedness of the brain. They talk about how ideas are linked together in networks and how activating one concept can trigger a cascade of related ideas.
Oh, right, like spreading activation.
Exactly. These connectionist models might offer a way to bridge the gap between modular and non-modular accounts of the mind.
Yeah. So it's not a simple either black and white kind of thing. There's probably a lot of specialization, but also a lot of integration and interaction between different parts of the brain.
That's what's emerging from the research. It's a complex interplay.
It really makes you appreciate how incredibly complex the brain is
Absolutely.
and how much we still have to learn about it.
For sure.
But for now, maybe we should focus on one area where this idea of modularity is often brought up: vision.
Okay, sounds good. Vision is a great example.
Yeah. So let's dive into the visual system and see what we can learn about how modularity might be at work there.
Let's do it. So before we dive into vision, I think it's worth mentioning, even the strongest supporters of modularity don't think these specialized units are completely isolated.
Right, like we were just discussing with language. It's not like these modules are totally walled off from each other.
Exactly.
Our knowledge and experiences, they clearly influence how we understand language, even if there is some dedicated language module.
Right.
So how do these modules actually communicate with each other? Like, is there some central control room in our brain directing the flow of information?
That's a great question, and it's something that researchers are still trying to figure out. But instead of a single control room, imagine more like a complex network of roads connecting different cities.
Okay, so each city is like a module.
Exactly. And there are rules and signals to ensure everything flows smoothly.
But how does that work in practice? Can you give me a specific example of how these modules might interact in everyday life?
Sure, think about reading. As your eyes scan the words on a page, your visual modules are busily processing the shapes of the letters, recognizing patterns.
Okay.
But that information is meaningless until it's passed on to your language modules.
So it's like the visual module is a mail carrier delivering a letter to the language module.
That's a perfect analogy. And once the language module receives that letter, it starts deciphering the message, figuring out the grammar, the meaning, the context.
So what happens then? Does the language module send a memo to the thinking module?
It's more like a two-way conversation. The language module might consult with your memory modules to retrieve relevant information.
Right.
Or it might ping your emotional modules to gauge your reaction to the words.
So it's this chain reaction with different modules activating and influencing each other as we process information.
Precisely. And all of this is happening in milliseconds, effortlessly and unconsciously. It's a testament to the incredible efficiency and complexity of our brains.
Yeah. It's amazing when you really think about it.
Yeah.
All these different processes working together seamlessly.
Yeah.
But as we've been discussing, this very complexity also makes it really difficult to pinpoint exactly how these modules interact and where the boundaries of their encapsulation lie.
Right. We talked about those challenges to strict modularity, like this sleeping dogs strategy,
Right.
and the idea that logic might be a more general process.
Exactly. And these alternative perspectives are important to keep in mind because they remind us to be cautious about oversimplifying our models of the mind.
Yeah, it's tempting to try to make things neat and tidy,
It is.
but the brain is anything but.
It's messy and complex and fascinating.
Exactly. One thing that I found really interesting from these papers is how even basic processes like vision might be more influenced by our knowledge and experiences than we realize.
That's a really important point. It really highlights this interconnectedness of different cognitive functions.
Yeah, even in something as seemingly straightforward as visual perception, there's this back and forth between modular processes and those higher level cognitive systems we were talking about. Right, it's not just a case of our eyes sending a raw image to our brains for instant understanding. Our brains are actively constructing our perception, using what we already know to make sense of the incoming information.
So it's like our brains are working as detectives, piecing together clues to create a cohesive picture.
I love that analogy. It really captures the essence of how our visual system works.
And we also briefly touched on this idea of individual differences.
Right.
That even though there might be some general organizational principles, every brain is unique.
Absolutely. It's like cars.
Yeah.
While all cars share the same basic components, each one has its own quirks and performance characteristics.
I like that analogy. So understanding these individual differences is key, right? It could be really important for fields like education and medicine.
For sure. Imagine being able to tailor educational approaches or medical treatments to an individual's specific brain wiring.
Yeah, that's amazing to think about.
It is, and it's something that researchers are actively exploring.
So to kind of summarize what we've covered so far, this idea of modularity has given us these really incredible insights into how the mind works. But it's not as simple as just saying our brains are divided into neat little compartments.
Right.
We've seen how there's this constant interplay between these specialized modules and those more general cognitive processes.
Exactly.
And those alternative views like sleeping dogs and the debate about the modularity of logic, they remind us that there's still a lot we don't fully understand.
For sure. It's a constantly evolving field.
Which is what makes it so exciting.
Absolutely.
So you ready to dive into some of those philosophical implications we talked about earlier?
Let's do it. I think it's time to tackle the big questions.
All right. This is where things get really interesting.
I agree. Let's see what philosophical insights we can uncover.
Okay, so we've talked about free will and the mind-body problem, but what about this idea of a modular mind? Like, how does it affect our sense of self? Does it change how we see ourselves?
That's a really interesting question, and it's one that philosophers have been grappling with, as we learn more about the brain and this idea of modularity. It really does make you question some fundamental assumptions about who we are.
Yeah, like if our minds are basically collections of modules, does that mean there's no real me in there?
Well, it's a radical idea, but some philosophers argue that a unified self, a singular I, might actually be more of an illusion than a reality.
Wait, really? So you're saying because our mental functions are spread out across these different modules, there might not be one central me running the show?
It's a mind-bending concept, isn't it? Think of it like this. Instead of your mind being like a monarchy with a single ruler, it's more like a democracy where different modules contribute to the overall decision-making process.
Okay, so instead of one CEO making all the decisions, it's more like a company with different departments, each with its own expertise and responsibilities.
Exactly. And this really challenges our traditional idea of a unified self.
I mean, it makes sense in a way,
Yeah.
but it's also kind of freaky to think about.
Yeah, it definitely makes you question some fundamental assumptions.
But if there's no central me, does that mean my sense of self is just a bunch of fragmented modules?
It's a question that's still being debated, but there are some who propose that even with a modular mind, there could still be a sense of self that emerges from the interaction of those modules.
Okay, so maybe it's not that the self disappears completely, but that it's a more dynamic process,
Yeah.
constantly being shaped by how these different mental components work together.
Exactly. And it's not just a random jumble of activity either. There's still a sense of coherence and continuity to our experiences.
So even without a single CEO running the company, there's still an overall direction and purpose that emerges from the collaboration of all the departments.
That's a great analogy. And it kind of makes sense when you think about how our brains have evolved over time.
How so?
Well, having specialized modules for different tasks would have been incredibly advantageous for our ancestors, right? It allowed them to process information more efficiently and respond to their environment more effectively.
Right, like dedicated modules for things like recognizing predators or finding food.
Exactly. But at the same time, they needed a way to integrate all that information and make decisions as a whole organism.
So it's like evolution favored both specialization and integration.
Precisely. Which might explain why our minds have this modular structure, but also this capacity for a unified sense of self.
This has been a really amazing conversation. It's made me think about my own mind in a completely different way.
I'm glad to hear that. It's really fascinating stuff, isn't it?
It is, and even though we've covered so much ground, I feel like we've only scratched the surface.
Oh, absolutely. There's still so much we don't know about the brain and how it creates our conscious experience.
Which is kind of exciting, right? There's still so much left to discover.
Exactly. It's
Yeah.
a vast and uncharted territory, and every new study brings us a little bit closer to understanding the mysteries of the mind.
Well, on that note, I think it's time to wrap up this deep dive.
Sounds good.
It's been an absolute pleasure exploring these ideas with you. Thank you so much for sharing your expertise.
The pleasure was all mine. It's always a joy to talk about the brain and the mind.
And to all of you listening, thank you for joining us on this deep dive into the modularity of mind. We hope you've enjoyed the exploration as much as we have, and remember, curiosity is the key that unlocks the doors to understanding. Until next time, keep those minds open and engaged.